We're going to be looking at the Edexcel FP2 question on first order differential equations from June 2011, question 3. This question wants us to find the general solution of the given differential equation, noting that x needs to be a positive value, and we need to ensure that we give the answer in the form y equals f of x. So to start with, we need to ensure that we have the correct form of the differential equation. We certainly can't separate the variables, so the only method that we can apply is to use an integrating factor. And in order to use the integrating factor successfully, we need to divide through by x. So we need to ensure that we have dy by dx on its own plus 5 over xy equals ln x, and don't forget to divide the right hand side by x as well. So we're now in a position to find the integrating factor. We have it in the correct form. We divide it through by x, and it's this term here that we're going to use to find this integrating factor. So the integrating factor for this problem will be e to the integral of 5 over x dx, which is e to the 5 ln x. You don't need a plus c on that little integral, we're only looking for the integrating factor. Then we can use our power law to write 5 ln x is ln x to the power 5, and then we know that exponentials and lns are inverse functions of each other, so that we end up with just x to the power 5 as our integrating factor. So now if we multiply all the way through by this new integrating factor, we should have the correct form to proceed with this differential equation. So we'll have x to the 5 dy by dx. I'm just bracketing the terms to make it clear what's happening. 5 over x times x to the 5 will be 5x to the 4. And don't forget to multiply the right hand side by x to the power 5 to give us x cubed ln x. And if you look at this left hand side, the derivative of x to the 5 is 5x to the 4, so the left hand side can be written as the derivative of a product, and that product will be x to the 5 times y. Okay, so now I know the derivative of x to the 5y is x cubed ln x. Now if I integrate both sides with respect to x, when I integrate the derivative of that bracket, I will be left with that bracket. But I will also have to integrate x to the cubed ln x with respect to x in order to produce the solution to the problem. In order to do the integral on the right hand side, we're going to have to use integration by parts. So I'm going to need a term called u and a term called dv by dx. Ln x is the obvious term to differentiate, so it's going to be ln x is going to be the u. It's much easier to differentiate ln x than to attempt to integrate it. So du by dx will be 1 over x. Therefore dv by dx is going to be x cubed, and when I integrate that term I'll get v is a quarter x to the 4. So now when I use parts, I'm going to get x to the 5y is, and now we're using parts, it's u times v. So I'm going to write that as a quarter x to the 4. I'm going to put that in before the logarithm just to make it clearer and easier to write, minus the integral of 1 over x times a quarter x to the 4 dx. Now quite often I've seen students get to this new integral and stop. They sometimes are not sure what to do and don't appreciate that this can simply be cancelled down and simplified to a quarter x cubed with respect to x. So we now have a new integral which is much easier than the original one, and will simply be a 16th x to the 4. Don't forget, you can now need your constant of integration. The question wanted y to be a function of x, so all we do to finish off this question is to divide through by x to the 5, all the way through. So y is ln x over 4x minus 1 over 16x, and don't forget to divide c by x to the 5 as well. And there is your final answer. The mark scheme for this question offers a method mark for looking for the integrating factor, an accuracy mark for the correct integrating factor, a method mark for correctly simplifying the differential equation. There's also a method mark for applying integration by parts, an accuracy mark for the correct use of integration by parts, an accuracy mark for identifying the new integral that is found after integration by parts. There's a method mark for the correct integration, and the accuracy mark at the end for dividing through by x to the power 5 to get the correct expression for y. You can find extra information on the Further Mathematics Support Programme website at www.furthermathematics.org.uk.